talk about how to compare two fractions. We'll start off pretty easy. I say this is easy because just look at the names of the two fractions. 2/7 has got to be less than 3/7. We could also think about the number line. To find these two on the number line, we take the number line between 0 and 1 and we split it up into 7 equal pieces. 2/7, that's 2 pieces. 3/7, that's 3 pieces. 3 is bigger than 2. We can also think about fraction multiplication. 3/7 is 3 times 1/7. 2/7 is 2 times 1/7. 2 is something that's going to be less than 3 of something. So you see that 3/7 is greater than 2/7. In the same way, we can see that anytime we compare two fractions that have the same denominator, the fraction with the larger numerator is the larger fraction. So now that we know how to handle fractions with the same denominator, let's take a look at fractions with the same numerator. I'm going to start off again by looking at fraction multiplication. We can think of 7/9 as 7 times 1/9, or 7/9. And 7/8, of course, is 7 times 1/8. So now we see that all we have to do is compare 1/9 and 1/8. And once again, we can think about the number line. To find these on the number line, we take the number line between 0 and 1 and we split it up into a bunch of pieces. To find 1/8, we split this segment up into 8 equal pieces. To find 1/9, we split the number line between 0 and 1 into 9 pieces. Now, if we're going to split this into 9 equal pieces, those pieces are going to be smaller than if we split it into 8 equal pieces. So 1/8 must be greater than 1/9, which tells us, of course, that 7/8 is greater than 7/9. So now we see how to compare fractions that have the same numerator. The one with the smaller denominator is the larger fraction. Now, I don't want you to memorize that as a new rule. Just think about it this way each time. You'll see how to compare any two fractions that have the same numerator. So we've handled same denominator, we've handled same numerator. But what if the numerators are different and the denominators are different? Now this is a completely different kind of problem. But can we turn this into a problem we already know how to do? That's one of my favorite strategies. I see something I haven't seen before, turn it into something I already know how to handle. So what I'm going to do is I'm going to try to turn this 2/3 into a fraction with denominator 9, because I know how to compare fractions that have the same denominator. And back when we were talking about simplifying fractions, we did talk about how to change the denominator of a fraction and not change the value of the fraction. Remember, we had 3/6, common factor of 3 in the numerator and denominator. We cancel that out, we end up with 1/2. Here I have 2/3. I want to put a new factor into the denominator. I want to multiply this denominator by 3. Now, if I multiply the denominator by 3, I have to multiply the numerator by 3 as well. That's just strategically multiplying by 1. We're going to multiply by 3/3. This is just 1, so I'm not changing the value. 2/3 is equal to 2/3 times 1, of course. We know how to multiply fractions. 2 times 3 is 6. And 3 times 3 is 9. Now, if you look at it going in this direction, you'll recognize this is simplifying fractions, going from 6/9, factoring out the 3's and canceling those out to get 2/3. When we go this way, it looks like we're complicating the fraction. We're simplifying the problem. Now we have our two fractions with the same denominator. They're both 9. We call this the common denominator of the two fractions. And now we can see which is larger. Once the denominators are the same, all we have to do is compare the numerators, and we see that 7/9 is greater than 6/9. So we know how to handle fractions that have different denominators. Let's try one more. Make sure we have this down. We're going to compare 3/8 and 4/9. So we saw what we did last time. We multiplied the denominator of one fraction by something to get the other denominator. So here we're going to multiply 8 by... If I multiply 8 by 1, I get 8. I multiply 8 by 2, I get 16. There's no integer I can multiply 8 by to get 9. How am I going to make these denominators the same? Well, there's nothing that says I can only change one denominator. Let's change them both. I can multiply this one by 9, this one by 8. And then the denominators will both be 9 times 8. And that's, 9 times 8 is the same as 8 times 9. It doesn't matter what order you multiply the two numbers in. So I'm going to take my 3/8. And I'm going to strategically multiply that by 1. 9/9. I'm going to take my 4/9. And that one I'm going to multiply by 8/8. So that I'll be multiplying 8 and 9 in both denominators, then my denominators will be the same. So the numerators here, 3 times 9, that's 27. Denominator, 8 times 9, 72. Down here, 4 times 8 is 32. Denominator is 72. As planned, the denominators are the same, so now we can compare them. We can see that 32 is greater than 27, so 4/9 is greater than 3/8, and now we have our strategy for comparing any two positive fractions. All I have to do is make the denominators the same, and then we're done.